Hello, students. We've got a lot to cover today, so I'm going to kind of get right into it. It's our Unit 6 review. Please pay attention to the prompt about calm down strategies and spend a minute on that. We have our Unit 6 review, and as you'll see here, these are all the topics that we worked on in Unit 6. So make sure you're familiar with each one of them. So your assignment today will be to complete the do now, the unit review, the exit ticket. The exit ticket is basically submit your unit review. So if you're a distance learner, you'll submit your photo on Teams. If you're in person, you'll show me your completed work. So for homework, I want you to study for the test tomorrow. And remember, your Unit 6 homework is due in Teams, and your interactive notebook assignment needs to be completed and submitted by Friday. So your exit ticket today is to just submit or show me, if you're in person, your completed review. So I'm going to skip over the do now, and we'll talk about it in class. I want to get going with this video. So we're going to start with the exponent rules. So the product rule is when you have x to the a times x to the b, the product of that will be x to the a plus b. So we add the exponents. With the power rule, when you raise a power to a power, x to the a raised to x to the b, you will multiply the exponents. With the quotient rule, when you divide x to the a power by x to the b, you will subtract the denominator exponent from the numerator exponent. And if you have a negative exponent, you will make it a positive exponent and put it in the denominator. So when you add or subtract monomials, remember you must combine like terms. So you're going to look for those like terms and combine those, okay? The exponents do not change. Okay, so let's get into some of these problems. So we're asked to simplify 6ab minus 2ab. We have like exponents. So 6 minus 8 is negative 2, so that's negative 2ab. Negative 2xy squared minus 4xy plus 6xy squared. The 4xy will not combine. Negative 2 plus 6 is 4xy squared minus 4xy. To subtract negative 6(5)b to the fifth from, this is our turnaround phrase, 8b to the fifth, that would be 8b to the fifth power minus 6b to the fifth power. We're subtracting a negative 6b. So remember, we have a not, so we make it positive. 8 plus 6, 14b to the fifth power. Number 4. So why don't you try some of these and then come back to the video. So we have negative 7 to the negative fourth power times 5 to the negative 2 power. 7 times 5 is 35. So that would be negative 35. And we add the exponents. Negative 4 minus 2 is negative 6. And then we have to rewrite that. So we'll put the negative 35 is fine in the numerator. It's negative exponents we don't want in the denominator. So here's our final answer. 5v4 raised to the second power times 2v3 times v. So first we'll evaluate this. So 5 times 5 is 25. And v, 4 times 2 is 8 times 2v3 times v, there's an invisible 1. So this would be 2v to the fourth power. Then 25 times 2 is 50, and we add those exponents, so that would be v to the 12th power. Number 6, we have to raise this quantity to the exponent of 2, so that will be negative a to the 12th power, b to the second power. But I made a mistake. The a is in parentheses, so a negative times a negative is a positive, so that negative goes away. Okay, so negative a times negative a, or negative a times 12, that's an even exponent. So this negative will become positive. So we have a to the 12th, b to the second power, and I know I've mentioned this before. When you add and subtract these and you have to do something on one side or the other, they will often make it so you end up with like terms, which we have here. So it's a to the 12th, b to the second, plus 9. Again, a to the 12th, b to the second power. Now remember, this is an invisible 1. So it's 9 plus 1 is 10, a to the 12th, b to the second power. Okay, number 7. We have negative 2. We have to do some work on this center part. So we've got negative 2y to the 4th. And remember, the 4 only applies to the y, not to the negative 2, times x to the power of 2, y to the power of 6, minus 13, x to the power of 2, y to the power of 10. So that would be negative 2. I think the way we should do it, we'll do those x squared terms first, okay? So we would have negative 15 x squared. We have 1 here, 1 x squared there. We have, no, that would actually be negative 14 x squared, because we have 1 x squared and 1 y to the 6. So that's going to be negative 15, negative 14 x squared, y to the 10th. Okay, I wanted to go back over that. I didn't take into consideration this multiplication right here. So we've got to work this first. Negative 2 times x squared is going to be negative 2x squared. And y times y is going to be 2 times y to the 4th times y to the 3rd, which will be, oops, I forgot the 6. This will be a 6. 4 plus 6 is 10, so that's y to the 10th, minus 13x squared, y to the 10th. Okay, so we've got negative 2 minus 13, because we have like terms here, x squared, y to the 10th. Negative 2 minus 13 is negative 15 x squared, y to the 10th. And don't do what I did. My eyes are going on me, and I missed that little multiplication in the center. So work a little slow with these. Okay, r to the 6 minus, so it's 6 minus 5, so that would be r. S would be 7 minus 4, which would be s to the 3rd. And t, 2 minus 2 is t to the 0, which equals 1, so that just goes away. Okay, number 6, or 9, excuse me. Let's work with the denominator here. We have a numerator, negative, actually we can work with the numerator too. We have negative 3 to the 2nd power, x to the 12th power. And negative 3 to the 2nd power is going to be 9, so we might as well do that right now. So that's going to be negative 3 times negative 3 is a positive 9, x to the 12th power, and in the denominator, 5 times 3, 15, x to the 6th power. Okay, so now 9 over 15 can be reduced to 3 over 5, And x 12 minus 6, that would be x to the 6th power. Okay, number 10, we have a little bit of work we have to do here. So 4 to the 2nd power, 4 times 4 is 16. X, 4 times 2, 8. Y, 2 times 2, 4. In the denominator, remember, the 2 applies to everything inside the parentheses. 6 times 6 is 36. X 2, Y 2. Now we simplify 16 over 36 by dividing by 4. So that would be 4 over 9, x to the 6, y, 4 minus 2 is 2. Number 11, we'll work with this numerator first. 7 times 3 is 21. K, negative 8 minus 2. Remember, we add the exponents, so that would be a negative 10 over 6k to the 2nd power. Now we simplify 21 over 6, which are both divisible by 3. So that would be 7 over 2. And then for the exponent, we have negative 10 minus 2, which would be k to the negative 12. And we need to put that in the denominator. So 7 in the numerator, 2k to the 12 in the denominator. And number 12, negative 9 over 27. 9 goes into itself once. 9 goes into 27 3 times. And n would be 8 minus 10, which would be negative 2. So we're going to rewrite that with the n in the denominator with a positive exponent of 2. And number 13. So we have a to the 12th, b to the negative 3, and then let's distribute that negative 4 exponent, a to the negative 4, b to the negative 4, and 12 minus a negative 4 is actually 16, so that's a positive 16 on the a, and b, negative 3 minus a negative 4 is a positive 1. So our final answer is a to the 16th power b. Okay, number 14. First, we're going to do the multiplication on the left. So 3/4 m7 n6 times m to the 5th power n to the 9th power will be 3/4. So it's 3/4 times 1 here. And m7 plus 5 is 12. And n, 6 plus 9 is 15. Minus, now 1/2 to the 3rd power is 1/2 times 1/2 times 1/2. So that would be 1/8 m. 4 times 3 is 12, and 5 times 3 is 15. So now we have our like terms, so we can subtract. So it basically comes down to 3/4 minus 1/2 and minus 1/8, minus 1/8. We would convert this to 6/8. So it would be 6/8 minus 1/8, which is 5/8, m to the 12th n to the 15th power. And number 15, we have negative 4y to the 3rd raised to the 2nd power. So let's handle that right now. That's going to be 16y to the 6th power times xy to the 4th raised to the 3rd power. So that'll be x to the 3rd, y to the 12th power, plus 7x to the 3rd, y to the 18th power. So we need to do the multiplication first. 16 times 1 is 16. And we have our x to the 3rd, y to the 6 plus 12, 18 power, plus 7x to the 3rd, y to the 18th power. So we've got like terms. 16 plus 7 equals 23, x to the third, y to the 18th power. Now, we've got the geometric applications, page 2. So we're asked to find the perimeter and the area of this figure. So remember, this side is also going to be 13x, and this side will also be 4x squared y. So for the perimeter, it's 2 times the length times 2 times width. So P equals 2 times 4x squared y plus 2 times 13x, which would equal 8x squared y plus 26x. And those are not like terms, so that's our final answer. The area is length times width, so that would be 4x squared y times 13x. 4 times 13 is 52. X has an invisible exponent of 1. We add exponents. That would be x to the third, y, a final answer on the area. Now, so for the trapezoid, we're going to do the area first. They just want the area. So the area is going to equal 1/2 of the 2a3b plus the 9a3b, okay, times this 6a. So it's 2a3b plus 9a3b multiplied by 6a squared. So let's do the parenthesis first. So that would be 1/2 times 11a3b times 6a squared, and 11 times 6 is 66. Half of that is 33. And we have to add the exponent. 3 plus 2 is 5, and we have our b. And that's our final answer. For scientific notation, we're going to have to do some conversions. We're asked to give each answer in scientific notation. So the first one is an addition one. So that would be 8.6 times 10 to the negative fourth plus 6.7. Well, what I want to do is make this a -4. So I'm going to move the decimal point one place, and then this becomes a -4. So it would be 0.67 times 10 to the negative fourth. Now I can add them because I have like terms. That would be 9.27 times 10 to the negative fourth. Number 19, I need to do some conversions on that as well. So I'm going to move the decimal point 2 places here, add a 0, and this will be 10 to the third. So it's 3.5 times 10 to the third minus 0.09 times 10 to the third. I have to have those like exponents, and that would be 3.5 times 0.09, and that would be 3.41 times 10 to the third. Number 20, we have multiplication. So it would be 5.6 times 4.5, which would be 2.52 times 10. I'm sorry, it'd be 25.2, not 2.52. 25.2 times 10 to the fourth. Now that's not proper scientific notation. We have to move this decimal point, which means, I'm sorry, that should be a 10 right there. Okay, we need to move that decimal point, and that's going to raise this. So when this gets smaller, the exponent gets bigger. So it'll be 2.52 times 10 to the 11th power. Oops, let me rewrite it. Okay, let's stay that time. Okay, number 21. I'm going to multiply the numbers in the front first, and 7.6 times 8.9 is 67.64 times 10 to the negative 9. Okay, but this is not proper scientific notation, so I'm going to move the decimal point one place, 6.764 times 10, and this exponent has to become larger by 1, so that would be 10 to the negative 8. And then number 22, division, we use the division rules. So 3.9 divided by 4 is 0.975 times 10 to the negative 12 minus 4 is negative 16, but we're going to move the decimal point 1 to the right, so that would be 9.75 because that's our proper notation, times, so this is going to get smaller, 10 to the negative 17th. And we have one more division problem. 1.75 divided by 5 is 0.35. And we have 5 minus a negative 3, which would be 10 to the 8th. We need to move the decimal point once to the right, which will make our exponent smaller. So it would be 3.5 times 10 to the 7th. Now let's move on. We have an application. The continent of North America has an area of approximately 9.4 times 10 to the 6 miles. The area of Asia is approximately 1.74 times 10 to the 7th miles. Approximately how many square miles larger is Asia than North America? So if Asia is larger, we're going to subtract North America from Asia. So that would be 1.74 times 10 to the 7th. And then we are going to subtract. Now, we need same exponents. So I'm going to move the decimal point over. I'm going to make it 0.94 times 10 to the 7th. Now I can subtract. So I subtract 0.94 from 1.74, and I have 0.8 times 10 to the 7th. Now I need to move the decimal point again so that I have this in proper scientific notation. So that would be 8 times 10 to the 6th power. Now we're going to graph some exponential functions. Remember to do our xy values. So I'm going to try -2, -1, 0, 1, and 2. And when x is -2, y is -3.8. When x is -1, y is -3.6. That's an irrational number. When x is 0, y is -3. When x is 1, y is -1. When x is 2, y is 5. So the graph is going to look something like this. So we've got that 0, -3, 1, -1, and 2, 5. So approximately like this. But I also put it on Desmos. So let's take a look at it. There it is. So we have the y-intercept at 0, -3. We can see that it's growth, and the domain is all real numbers. And there's an asymptote at y equals -4. So let's fill that in. This is a growth with a domain of all real numbers. The range is y is greater than -4. Our y-intercept is 0, -3, and our asymptote is y equals -4. Okay, let's get some values for number 26. And I'm going to use the same values, -2, -1, 0, 1, 2. And I'll just give you the y values. That's 1/8 and 1/16. Okay, now let's just take a look at the graph on Desmos. So there it is. This is a decay graph. The domain, the x values will cover the entire x-axis, so the domain is all real numbers. Our asymptote is y equals 0, so our range is y is greater than 0. Our y-intercept is the point 0, 0.5, so it's 1/2. So this is a decay function with a domain of all real numbers. A range of y is greater than 0. The y-intercept is 0, 0.5, and the asymptote is y equals 0. And we've got one more to do. And again, I'm going to use the same -2, -1, 0, 1, 2. And our y values, 1.375, 1.75, 2.5, 4, and 7. And let's take a look at the graph. It's the green one, and it is exponential growth. The domain is all real numbers. The y-intercept is 0, 2.5, so 0, 2.5 on the y-axis. And our asymptote is y equals 1, so our range is y is greater than 1. So it's a growth function. The domain is all real numbers. I could have used our abbreviation. The word range, y is greater than 1. The asymptote, 0, 2.5 on the y-axis. And our asymptote, or y-intercept is 0, 2.5. Our asymptote is y equals 1. So let's move on to the growth and decay applications. The exponential growth function, y equals a times the quantity of 1 plus r raised to the t value. So this is a is our initial value, r is the rate, t is time in years. The exponential decay function, y equals a times the quantity of 1 minus r, the rate raised to the exponent of t. Population of the city is 422,000 and increases by 12% each year. It's a growth function. Use the function to find the population of the city after 8 years. So the rule will be y equals 422,000 times the quantity of 1 plus 0.12 raised to the 8th power. And when I evaluate that, I get, after 8 years, there'll be 1,044,856 people. Remember, with people problems, we always round off to a whole number. Number 29, a car bought for $13,000 depreciates at 15% a year. This is a decay function. So we're going to use an exponential function to find the value of the car after 5 years. So the rule would be y equals 13,000 times the quantity of 1 minus 0.15, and that will be raised to the 8th power. And when we evaluate that, we find that the car, 5 years, not 8 years. So it's 5 years. And when we evaluate that, we see that the car is worth $5,768.17. And now, finally, Scott purchased a painting in 2006 for $1,250. Good for him, because its value increased by 6% of each year, straight line appreciation. And we want to use an exponential function to find the value of the painting in 2017. From 2006 to 2017, that's 11 years. So our equation y equals 1,250 times 1 plus 6%, 0.06, raised to 11. When we evaluate that, our answer is $2,372.87. On to geometric sequences. So let's given the sequence 2, 6, -18, write a rule, then find a sub 8, the 8th term in the sequence. So the rule, a sub n equals, so it looks like we're multiplying by -3. Okay, so that's our common ratio is -3. So a sub n equals -2, the first term, times -3, I'll put that in parentheses, raised to the n minus 1 power. That's our rule. To find a of 8, we will multiply -2 times -3 raised 8 minus 1 is 7. We want to find the 8th, it's 8 minus 1, and we will get, when we evaluate that, 4,374. Now we have a decreasing sequence, and if you look carefully, each one of these is being divided by 2, okay, or multiplied by 1/2. So our rule would be a sub n equals 6,144, the first term in the sequence, multiplied by 1/2, raised to the n minus 1 power. In this case, we're asked to find the 15th term, so a sub 15 equals 6,144 times 1/2 raised to the 14th power. 15 minus 1 is 14, and all of that will equal 0.375. Give yourself a heads up 0, and that's our final answer. Now we're going to simplify radicals. So the square root of 64 plus the cube root of 8, that's 8 plus 2, which equals 10. Number 34, the cube root of -216 is -6, minus the square root of 169 is 13, and that equals -19. Number 5, we'll have to break this one down to the square root of 9 times the square root of 6, which would equal 3 times the square root of 6. Number 36, we'll break that one down to 16, square root of 16 times the square root of 15, which would be 4 times the square root of 15. Number 37, we have the square root of 160, which will be the square root of 16 times the square root of 10, which will be 4 the square root of 10. Number 38, the square root of 245. 245 is 49 times 5. So the square root of 49 times the square root of 5, which would equal 7, the square root of 5. Now, we've got some mixed examples. Number 39 would be 4 times 7. So the square root of 4 times the square root of 7. Now remember, if it's an odd number, we have to subtract 1. X to the 24th, y to the 8th, but that 1 we subtracted comes over here. So this would be 2x, 24 divided by 2, 12, y, 8 divided by 2 is 4, and then we just put the right side, 7x, and that's our final answer. So number 40 is 100. 200 is 100 times 2. And remember that n has an exponent of 1. Square root of 100 times the square root of 10. And the m to the 4 stays, but n has an exponent of 1, has to come over here. So on the left side, we have 10m to the second power times the square root of 10n. Did I say 10? This should be a 2. Sorry, my phone is ringing, my email is buzzing. 100 times 2, that should be a 2. I hope you caught it before I did. Okay, number 41, 153 can be thought of as 9 times 17. So that would be a to the 8th, because we have to put an a over here. B to the 10th, c to the 2nd, we need a c over there. So the left side, square root of 9 is 3, a 4, b 5, c 1, and we don't need to put that exponent, times 17ac, and that is our final answer. And number 42 can be thought of as, that's 19 times 19. So we're going to leave it there. 361, but x to the 8th, for here, we're going to have x. And then y16 can stay. So to the left side, this is 19, x to the 4th, y to the 8th, and then we have times the square root of x. Number 43, the square root of 80. Oh, cube root of 80. Well, the perfect cube is 8 times the cube root of 10. And the cube root of 8 is 2, so it would be 2. The cube root of 10, don't forget to put your 3, the index of 3 in your radical. So the cube root of negative 500 would be the cube root of negative 125 times the cube root of 4. 125 times 4 is 500. Only one of them can be negative. So when we evaluate this, negative 125 is negative 5 times negative 5 times negative 5. So it would be negative 5 cube root of 4 as your final answer. And then 384 can be thought of as 64 times 6. So the cube root of 64, and that's 8 times 8, times the cube root of 6. So the cube root of 64, is 8. I'm sorry, is 4. 4 times 4 times 4. Square root would be 8, but cube root is 4. Times the cube root of 6, and that's our final answer. And number 46 can be thought of as 216 times 3. And if you look back at your list of cube roots that we made in class, you'll know that 216 is a perfect cube. So 216 times 3, the cube root of 216 is 6, and then we have that remainder cube root of 3. Final answer. So your exit ticket today is to simply put everything, pictures of everything into Teams. And you may not get it all done in class, so you'll still have to upload photos, but make sure that you submit your completed work. Good job. You've worked hard. I've seen some improvement in Unit 6. I hope even more in Unit 7. Keep practicing, because as you do, you'll be great.